Hi everyone, welcome to the quadratic function unit. This video is just to give you an intro on the breakdown of how we're going to go about the quadratic function unit, what technologies we're going to be utilizing, and different tasks that you'll be going about. So first we're going to talk about how does this connect to what you already know. So this unit really builds off of skills from earlier this semester, specifically your absolute value transformations, solving quadratic equations, which we've done individualized as topics throughout the semester at different points in time. So we've done factoring in the polynomial unit. We've solved with square roots earlier in the semester, especially when we were talking about how do we simplify square roots and using those square root properties, the quadratic formula and discriminant, and completing the square. So we're going to be putting all these topics together and actually applying them to quadratic function graphs. And you're also going to be focusing on too whether which of the methods is the most effective and efficient to use. Because you will be utilizing square roots, you're going to need to apply those radical or square root properties and rationalizing the denominator at times. You're going to have imaginary numbers at times, so applying those properties of complex numbers. And really what that tells you about the graph of a quadratic function is kind of how we're going to be building off these prior knowledge skills. So technologies we're going to utilize in this unit are going to be Padlet, Google Tools. So we'll be using forum slides, docs. You might be using those to communicate with your group members and part of the performance task. I might be using them to share information and allow you guys to collaborate. So we'll be using Google Tools quite a bit. A tool called Answer Garden, which allows you to kind of submit answers to questions. MindMeister, which is a mind mapping tool. And then we're going to be, and the mind mapping tool also allows you guys to collaborate with one another, and we'll build a resource together. I'm going to be presenting tools and information to you through Edpuzzle and Nearpod. So I'm going to be sharing content with you that way. Informative questions will be built into those presentation tools that you guys will answer as you're watching the video and or going through the presentation. I'll also be using Screencast-O-Matic, which allows me to capture the screen of my presentation, which I'm currently using right now. Content-specific tools that we're going to be using are GeoGebra, Desmos, and then we're going to be using MathIXL, which we've used in the past, but we will be using quite a bit more. So the unit really focuses on these four essential questions. How are quadratic functions used to model, analyze, and interpret mathematical relationships? Why do we structure quadratic functions in different ways? What is the most appropriate method for solving quadratic equations if effectiveness and efficiency are goals? And really, how does one reason logically to solve quadratic equations? So the unit breakdown, it's kind of a 7-day unit, or at least predicting it to be that. So the very first lesson or day, we're going to review all of those methods for solving quadratic equations with really the focus on effectiveness and efficiency. It's been a little while since you've used some of these methods, so putting them all together in that sort of review with that added goal of efficiency is going to be useful for us. On the second lesson, we're actually going to build upon why did we learn these methods and how do they apply to graphing quadratic functions. And there's really three forms for graphing quadratic functions, or three forms of quadratic equations, I should say: standard form, vertex form, and intercept form. So those are kind of broken up 3 different days, where each day we're going to talk about how do we graph a quadratic function given its equation in different forms. On day 4, we'll start to put all forms together as well. And then the last few days of the unit really allow you to explore and apply your knowledge with quadratic functions to a performance task. So let's take a look at what this performance task is going to entail here.
Marcus Reynolds.
I ain't see it. My smart see it.
You have to try it. Really. Do it.
So no, you are not actually going to be going bungee jumping. That is not the task at hand. But you are going to be exploring uh, bungee jump stations and modeling a bungee jump station. So you're going to imagine you're an engineer who is potentially going to be hired by a local nature adventure park called Extreme Environment, and your job is to convince them that not only are you highly qualified for the job, but that your mathematical model is better than everybody else's mathematical model. And you also need to take on the business perspective of selling and kind of like going through the interview skills of why they should hire you. So the owners are considering a new attraction involving a bungee jump station from a rope bridge that goes across a chasm. And so the bridge will be a suspension bridge and the bungee jump station will be located on top of it. During your mathematical modeling, you're going to have to ensure that this bungee jump station meets the safety construction code requirements. And a lot of these skills that you're going to be utilizing involve a lot of the skills that we will be discussing in the quadratic function unit. So you're going to be applying them to real world applications. You're going to be working in groups to do so. You're going to be getting a choice of different tools that you want to use to kind of sell us on why you should be hired, why your group should be hired for the Extreme Environment Park. So this is definitely something to look forward to and kind of end our unit. So I look forward to working with you all throughout this unit, and I hope you enjoy it. Thanks.